So hello everyone, welcome to this new video. So in my previous video we were discussing with some problems related to periodic functions, right? So that we are going to continue in this video only, okay? So those who have not seen that previous video, please go and watch it. It is available in this playlist, okay? So there are two important problems in this video which I am going to solve. So let us see with those two problems now. The third question, already two problems are solved in my previous video. So this is the third question. A periodic function of period, they have mentioned period as 2 pi by omega, okay? And it is defined by f of t is equal to e sine omega t, where the limits of t are from 0 to pi by omega, and f of t it is 0 when the limits of t are from pi by omega to 2 pi by omega, okay, where e and omega are constant in this case. Okay, we should be showing that the Laplace transform of f of t while we solve, we should be getting our answer as e omega divided by s square plus omega square into 1 divided by 1 minus e to the power minus s pi by omega. Okay, while solving for Laplace transform, we should be getting this as our final answer. Okay, let us check whether we will be getting this or not. So according to the given condition f of t, we could be trying to draw the graph here, okay? F of t e sine omega t, and this is 0, right? Limits are from 0, pi by omega, 2 pi by omega, 3 pi by omega, and so on. First they are given f of t as e sine omega t from 0 to omega, pi by omega. That is, it is a sine wave, right? The first cycle of sine wave is starting from like this, right? Similarly, it is 0 from pi by omega to 2 pi by omega. That is, it is constant. Okay, so this is one full cycle here, one full period. It would be repeating here for different intervals. Okay, so hope it is clear, right? So we should be calculating f of t for this interval, Laplace transform at this interval. So let us calculate now. Given, according to the given question, what they have given is f of t plus t is equal to f of t plus, and the value of t is 2 pi by omega is equal to f of t. Okay, now Laplace transform of f of t is equal to, the formula is 0 to t e to the power minus st f of t dt, right? Now one divided by 1 minus e to the power minus s into the value of t is 2 pi by omega, right? Into, first the limits of 0 to t are from 0 to pi by omega. That is, the value is e to the power minus st e sine omega t dt, right? Plus 0 pi by omega to 2 pi by omega e to the power minus st, and the value is f of t is 0, right? 0 dt. Okay, so if you observe here the value is 0 itself, so this whole integral we cannot be considering only because it gets multiplied by 0. Okay, so this only we should be considering, that is 1 divided by 1 minus e to the power, so multiply 2 pi into s, so 2 pi s by omega into, so e I am taking it constant outside, 0 to pi by omega e to the power minus st sine omega t dt. Okay, So again, this integral, if you observe here, this is of the form integration of e to the power at sine bt dt, right? So for this we have one formula, right? That is e to the power at divided by a square plus b square into a sine omega t minus b a sine bt minus b cos bt, right? So according to the formula, the value of a and b are minus s and omega. Okay, so according to this, substitute the integral here. That is, rewrite it again. So take this e constant outside this bracket. So we are left with e divided by 1 minus e to the power minus 2 pi s by omega. So apply the integration here. What you will be getting, e to the power minus at divided by minus s is the whole square plus omega square into a sin bt, so minus s sin omega t minus b cos bt, that is omega cos omega t. Okay, so this is the integration and the limits are from 0 to pi by omega. Okay, now apply the limits. E divided by 1 minus e to the power minus 2 pi s by omega. Upper limit is pi by omega, so e to the power minus s, in place of t you put pi by omega, divided by minus s the whole square is s square plus omega square into minus s sin omega into pi by omega minus omega cos omega into pi by omega. Okay, so this is the upper limit minus the lower limit, that is again 0, e to the power minus a into 0 divided by s square plus omega square into minus s sin omega into 0, that is 0 itself, minus omega cos omega into 0, that is 0 itself. Okay, so now we would be left with 1 minus e to the power minus 2 pi s by omega. So here omega into pi by omega, so omega gets cancelled. Here also omega gets cancelled. We are left with minus s sin pi minus omega cos pi. Okay, that is e to the power minus s pi by omega divided by s square plus omega square into minus s sin pi. So sin pi is equal to 0, so this whole term would be equal to 0, and minus omega cos pi. Cos pi is equal to minus 1, so minus omega into minus 1, that is plus omega. Okay, minus the lower limit again, so e to the power 0, right? So it is 1 divided by s square plus omega square into s sin 0 minus s sin 0 is 0, so 0 minus omega cos 0. Cos 0 is equal to 1, so we are left with minus omega. Okay, so now you simplify the terms and write it again. So it would be e divided by 1 minus e to the power minus 2 pi s by omega into e to the power minus s pi by omega into omega divided by s square plus omega square. See, we had 0 plus omega, right? That is equal to omega plus since here we had minus here, also 0 minus omega is equal to minus omega, so minus into minus would be plus, right? So that's why I've written plus omega divided by s square plus omega square. Okay. So now in these two terms, if you observe carefully, omega divided by s square plus omega square is common. So that I will be taking outside. That is e divided by 1 minus e to the power minus 2 pi s by omega into omega divided by s square plus omega square I have taken common. So we are left in the bracket with e to the power minus s pi by omega plus 1. So this is left in the bracket. So now what I am doing is, this term is there, right? This I am sending back in the bracket. That is e omega divided by s square plus omega square into 1 plus e to the power minus s pi by omega divided by 1 minus e to the power minus 2 pi s by omega. Okay, so that is equal to e omega divided by s square plus omega square into 1 plus e to the power minus s pi by omega divided by, so again this is of the form a square minus b square, that is a plus b, a minus b. So here a square is 1 square and e to the power minus 2 pi s by omega, that is equal to e to the power minus pi s by omega the whole square, right? This is, if you simplify this, what we would be getting, powers, so multiply the powers, so we would be left with e to the power minus 2 pi s by omega, right? So that only is there here. So this is of the form a square minus b square. So the identity according to a square minus b square is equal to a plus b, a minus b, right? So that we are applying here. So a is 1 plus, what is b according to the analysis? So this is the value of b, that is e to the power minus pi s by omega into a minus b, e to the power minus pi s by omega. Okay, so now 1 plus e to the power minus s by omega, and here also we have 1 plus e to the power minus s pi by omega. So these two terms would be getting cancelled. So we are left with e omega divided by s square plus omega square into 1 divided by 1 minus e to the power minus s pi by omega. So this only we needed to prove, right? So this only we needed to prove, right, in the question. So that we have proved here. Okay. Laplace transform of f of t is equal to e omega divided by s square plus omega square into 1 divided by 1 minus e to the power minus s pi by omega. Okay. So these problems are easy if you go to solve step by step. Okay, just observe each steps very carefully during the integration, during the substitution of limits, and you should be knowing at which point of time what formula could be applied. Okay, if you know that thing, then these kind of problems are very easy to solve. Okay, so this is the answer for this, guys. Note it down. So we have one more problem. Let us solve it. So this is the last problem. A function f of t is defined by f of t is equal to t when the limits are from 0 to a, okay, 0 to a, and it is 2a minus t when the limits are from a to 2a, okay. If it's not visible, I'm telling you, f of t is defined by f of t is equal to t when limits of t are from 0 to a, and it is 2a minus t when the limits of t are from a to 2a, where f of t plus 2a is equal to f of t, okay. So the value of time period t is from 0 to 2a. At that single time interval, the waveform is repeating, okay. show that again we should be showing Laplace transform of f of t is equal to 1 by s square into tan h of as by 2. Okay. So this is one more thing we should be proving, that is while solving for Laplace transform we should be getting this as our answer. Okay. Let us see we would be getting it or not. First, according to the question, try to draw the waveform f of t and t 0, a, 2a, 3a, 4a, and it goes on. So from 0 to 2a, one time interval, the waveform is f of t is equal to t, they are mentioned. So if f of t would be equal to t, so f of 1 is 1, f of 2 is 2, so the line would be a straight line. Okay. And f of t from a to 2a, it is 2a minus t. So from this point itself, minus t, okay, it would be coming down. So it would be repeating like this. So this is a single time interval waveform. Okay. So this is of the form triangular waveform. Okay, this question. So this is triangular waveform. So according to this, now let us solve for Laplace transform. So formula is L of f of t is equal to 1 divided by 1 minus e to the power minus st, limits from 0 to t, integration e to the power minus st f of t dt. Okay. So now is equal to 1 divided by 1 minus e to the power, the value of t is equal to 2a, so minus 2as I am writing it, okay, into, first the limits are from 0 to a, e to the power st, the value of f of t is equal to t, plus from a to 2a, the value of f of t is 2a minus t, okay, dt. Now solve separately. So now for these two integrals, apply integration by parts. Okay, integration by parts formula you know, right? So if you don't know, let's recall it now. 1 divided by 1 minus e to the power minus 2as into, let us apply integration by parts here. So we have two terms. So the first term, let us consider t. So according to the integration by parts, first function into the integration of second function, that is integration of e to the power minus st is e to the power minus st divided by minus s, okay, minus integration of integrated function, that is whatever we have integrated, right, its integration, so that is e to the power minus st divided by s square into the differentiation of first function with respect to t. So differentiation of first function is, differentiation of t is 1. So this is the first part, limits are from 0 to a, plus the second term, the same way apply integration by parts, that is first function let us take 2a minus t into the integration of second function, that is e to the power minus st divided by minus s, minus integration of integrated function, that is again e to the power minus st divided by s square. This is actually minus s the whole square, so that is equal to s square only, into the differentiation of the first function, that is with respect to t. So here we don't have any t term, so differentiation of minus t is equal to minus 1. So if you multiply minus 1 here, so you minus into minus is here plus, write it at plus, that is equal to plus 1. Okay, so the limits are here from a to 2a. Okay, now apply upper limit and lower limit separately and solve it. Be very careful while solving. Check each and every term very carefully and put the limits. Okay, first the upper limit a e to the power minus sa divided by minus s, minus e to the power minus sa divided by s square. So this is the upper limit, minus lower limit is 0, that is 0 into e to the power 0 divided by minus s. So we are multiplying it with 0, so the first term goes. Okay, so second term, consider this term only, minus e to the power minus st, that is minus s into 0. So e to the power 0 we are left in the numerator, that is equal to 1 divided by s square. Okay, so this is for the first part we have applied upper limit minus lower limit. Now for the second part I'll do it here, plus. So first let us consider this as the first term, okay, and apply, that is e to the power minus s into 2a, that is minus 2as divided by s square and this term, if you apply this term here, the limits, that is 2a minus 2a, right? Here if you observe carefully, why I haven't written the first term, because if you apply the limits here, so you would be getting 2a minus 2a. 2a minus 2a is equal to 0. 0 multiplied by anything is 0. So this term, first term, we cannot be written. So that's why I have written directly the second term. Okay. Minus the lower limit, that is a. 2a minus a is a, e to the power minus as divided by minus s. Okay. Then what we are having, e to the power minus sa divided by s square. Okay, understood, right, how I have written? So now just simplify. Into first this term minus a e to the power minus as divided by s minus e to the power minus as by s square. So minus into minus is plus, so plus 1 by s square. Okay, so plus e to the power minus 2as by s square. So minus into minus is plus again, a into e to the power minus as by s. Minus into minus is plus again. So it is not here, it is not minus, it is plus. Why? Because if you observe carefully, upper limit we have applied here, okay, and when we apply lower limit, we would be getting plus here, okay. So that's why here minus into plus is equal to minus e to the power minus sa divided by s square. Okay, now here we have minus a e power minus as by s, and here we have plus a e power as minus as by s. So these two terms will be getting cancelled. So we will be left with 1 divided by 1 minus e to the power minus 2as into plus e to the power minus 2as by s square. First write that term, then e to the minus e to the power minus as by s square, and here also we have minus e to the power minus as by s square. So it is 2 times, so minus 2 times e to the power minus as by s square plus 1 by s square. Okay, so here 1 by s square is common in this bracket, so take that outside. So we are left with 1 by s square into 1 minus e to the power minus 2as into, we are left with e to the power minus 2as minus 2 e to the power minus as plus 1. Okay, so till here we have solved. Let us continue now. Again, if you observe this here, this is of the form a square minus 2ab plus b square. Okay, as I have solved in one previous problem, this is of the form a square minus 2ab plus b square. That is, what I am doing is I am taking this as a and this as b. So I'll rewrite this once again. 1 minus e to the power minus 2as 1 minus 2 e to the power minus as plus e to the power minus 2as. Okay, now a square minus 2ab plus b square. Okay, this is of the form this here. So 1 divided by s square 1 minus e to the power minus 2as here the value of a is 1 minus b. What is the value of b? Here we have b square. This is the b square term, that is e to the power minus 2as. Okay, so this also can be written as e to the power minus as the whole square. Okay, if you do this, we would be getting e to the power minus 2as only. Okay, so this is our value of b, that is e to the power minus as. Okay, a minus b the whole square. So 1 divided by s square into, so here this is of the form again a square minus b square again. Okay, where the identity says that it is a plus b into a minus b, so the value of b is mentioned here. So 1 plus e to the power minus as, 1 minus e to the power minus as, into, in the numerator we have 1 minus e to the power minus as the whole square. Okay, so one square term and this term would be getting cancelled, so we would be left with 1 by s square into 1 minus e to the power minus as divided by 1 plus e to the power minus as. Right? Now again, after this, multiply numerator and denominator by what is mentioned in the question, that is tan hyperbolic of as by 2, right? So that you do, multiply numerator and denominator by, in the bracket, e to the power as by 2, that is multiply numerator and denominator by e to the power as by 2. Okay, so let's do that. 1 by s square into e to the power as by 2 minus e to the power as by 2 into e to the power minus as divided by e to the power as by 2 plus e to the power as by 2 into e to the power minus as. Okay, now here the base is same, the powers are different, so we should be adding that powers according to the identity. So let us do that. As by 2 minus as, so take the LCM and solve. So here we will be getting as minus 2as by 2, that is equal to minus as by 2, right? So now it will be simplified and written as 1 by s square into e to the power as by 2 minus e to the power minus as by 2 divided by e to the power as by 2 plus e to the power minus as by 2. Okay, now if you observe here, this is again of the form sin h as by 2, and this is of the form cos h as by 2, right? So divide by 2, if you consider also, then it will be getting cancelled because it is either getting divided. Okay, so that's why if you consider this also, it will be getting cancelled and you would be left with only these terms, right? So we know that sin by cos is equal to tan, so our final answer we can write as L of f of t is equal to 1 by s square tan hyperbolic as by 2. Okay, so this is what we needed to prove, right? Hence proved. Okay, so this is the step-by-step procedure of solving this problem. If you have got the answer, so please note it down. That's all for this video, guys. We'll see you in the next video. Thank you.